Today's lesson is 11.4, Equivalent Fraction. The objective for today is that I will use models and computation to show equivalent fraction. The first thing we're going to look at is this problem right here. It says to look at these fraction strips and find as many fractions as you can that are equal to 1/3. Well, first of all, in your notes, you should have an equivalent fraction paper glued in. Your first one at the very top shows you 1 whole, and then we look at 1/2. So on yours, then we have, this would be 1/2, and you should have 1 whole above it. By looking at this one, I'm looking for many fractions as I can that are equal to 1/3. Well, if this is 1/3, remember that we count the whole total that I see. So for this one, I've got 1, 2, 3, 4, 5, 6. So this would be 2/6 looks equivalent. Okay, and then I go down here, I count my total. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 12. So it looks right here at about 4/12. Those are all equivalent because they show the same part of our whole. So looking at my whole again, let me erase what I've written. Looking at the whole parts that I have, the equivalent fractions show me the same portion of the whole long fraction strip. Shows me the same portion, just in different parts. And that's what an equivalent fraction is. In your notes, we need to have these vocabulary words written down. You may have to go to the next page and write them on the back if you've already glued in your big fraction page. A fraction describes one or more parts of a whole that is divided into equal parts. A numerator is the top number in a fraction, and it tells how many equal parts are described. The denominator is the bottom number, and it tells you how many equal parts are in all. I usually remember denominator because it starts with a D, and the denominator goes down in our fraction. Equivalent fractions are fractions that name the same part of a whole, but have different numerators and denominators. Again, you must have all of this vocabulary in your notes. It will help you later on. When we take a look at this problem, it says that Sarah ate 6/8 of a small mushroom pizza. What fraction is equivalent to 6/8? So what you see over here, this would be our equivalent fraction, or all of our fraction bars, which is similar to what you have glued in your notes already. Divide the numerator and the denominator by the same number to find an equivalent fraction. So the way that equivalent fractions work is I can always multiply or divide in order to find an equivalent fraction to that particular fraction I'm working with. For this one is being divided by 2 because both 6 and 8 are even, so that seems like the most simple one that we would divide by first. It's always a good place to start when you're trying to divide. Pick a number to divide by. So 6 divided by 2 would be 3, and 8 divided by 2 would be 4. So 3/4 is equivalent to 6/8. Check your answer using the fraction strip. So looking over here, we have 3/4 would be equivalent to 6/8. So if I look on here, I'm going to start by figuring out where 6/8 would be. So I go to the 8s down here, and I go 1, 2, 3, 4, 5, 6. So this part right here would show me 6/8. So we said that 3/4 would be equivalent. So 1, 2, 3/4 is equivalent. If I look, those do line up. So that is how those are equivalent. They show the same portion of the bar, but in different numerators and denominators. So we're going to try doing the multiplying and dividing to figure out equivalent fractions. So let's start with 1/2. If I have the fraction 1/2, I'm looking to create an equivalent fraction. When I'm doing any that have a 1 in the numerator, I usually know that I'm going to be multiplying. I always start as simple as I can, and I would just multiply by 2. It does not matter what you multiply by as long as you multiply by the same number on top and on bottom. So whatever you do to the top, you must do to the bottom. So 1 times 2 would be 2, and 2 times 2 would be 4. So an equivalent fraction to 1/2 would be 2/4, meaning they both show the same portion of a fraction strip, but with different numerators and denominators. Well, again, 2/3, I look at 2/3. Again, I like to go as simple as I can, and I always multiply by 2. I could multiply by something else if I wanted, but to make my life a little easier, I'm just going to multiply by 2. So 2 times 2 gives me 4. 3 times 2 gives me 6. So the equivalent fraction to 2/3 would be 4/6. Now this time, looking at 5/10, this time we're going to look at whether I should multiply or divide. So if I have the fraction 5/10, what I need to think to myself is think about my multiplication facts. I look at the number on top and I look at the number on bottom. Is there a number that goes into both of these numbers evenly that I could divide in order to get an equivalent fraction? Well, another trick that I always do is I look at the top number and I ask myself, does 5 go into 10? Is 5 a factor of 10? Well, 5 times 2 gives me 10. So that would tell me that if I divide by 5, both on the top and the bottom, then I can do that. So 5 divided by 5 would be 1. 10 divided by 5 would give me 2. So my fraction that's equivalent would be 1/2. We're going to do the same thing with 3/12. So if I have 3/12, I want to see if there's any number that I can divide by both 3 and 12 evenly. Well, again, I look at my top number and I ask myself, does 3 go into 12? If it does, then that means I'm just going to divide by that number. Any number divided by itself is always 1. So 3 divided by 3 would be 1. 12 divided by 3 would give me 4. So 3/12 is equivalent to 1/4. So notice on the top 2, I multiplied. On the bottom 2, I divided. I can do either way in order to find an equivalent fraction. Now, I want you to give it a try in your notes, and this time on 1 and 2, they're telling you what you should do. But for numbers 3 and 4, don't worry about 5 and 6 today, but worry about 3 and 4. You already know what a number needs to be. So, for example, if I have 5, 6, I know that 12 is what I want to make the equivalent fraction. So I have to look at my answers. Which if I'm trying to get 12, I have to think to myself, what do I do to 6 in order for it to become a 12? Well, if it's getting bigger, I know it has to be multiplication. So 6 times what gives me 12? Whatever I do at the bottom, I have to do to the top. Okay, you'll do the same thing. You'll do the same thing looking over here. But this time, 10 needs to become a 5. Well, it's getting smaller, so I know I have to divide. So I have to think to myself, 10 divided by what would give me 5? Or 5 times what gives me 10 is another way to think about that. Have 1, 2, 3, and 4 done in your notes and ready to go.